Okay, let's talk about radicals. Well, the last lesson we talked about was exponents. And these were the operations for exponents here that we went through. Okay. Then I left these two problems out and I asked for everyone to solve these. And in order to solve these, you have to know radicals. And the radical and exponent operations are similar. Okay? So, first, let's talk about radical operations, and then we'll come back to solve these problems. Okay? Okay, the first thing I want to talk about here, and let me get my pen back. First thing I want to talk about is radicals and the square root. And everyone knows that the square root of 4 is equal to 2. Okay? And whenever you take the square root, you're taking a plus or minus. Okay? Because this is why. We have what number can I multiply by itself twice to get 4? Well, 2 times 2 is equal to 4. So 2 times 2 is 2 squared is equal to 4. Okay? And if I take the square root of both sides, then I get the square root of 2 squared is 2, and the square root of 4 is the square root of 4. So the square root of 4 is equal to 2. Okay? But first, I want to talk to you about the square root, or what's essentially called a radical. Okay? So let's draw a little box around that. What a lot of students don't understand is that when you say the square root of 4, essentially what you're saying is the second root of 4. And most students don't know that. Okay, and then why you didn't learn it, I don't know. Most of the times the instructor tells you to read a chapter and you don't read it, and that's where that's probably located. Okay, but essentially when you take the square root, you're talking about the second root. Okay, and just like 1 times, let's say we have x. Okay, well, really x is essentially 1 times x. Okay, but we don't put the 1, we just write x. Okay, so just like we write the square root, we don't put second index. Okay, we just write square root. Okay, now you don't put the index until you get a different index. Okay, so let me explain a radical. When I say the square root of 4, essentially what I'm saying is the second index of 4. So that means that could be written as 4 raised to the power of 1/2. Okay? That's what you're essentially saying when you say the square root of 4. Okay? So if I said square the square root of 4, if I say square the square root of 4, how you would write that is you would write 4 raised to the power of 1/2 squared. Okay? Now, from the operation of m raised to the power of n is equal to a to the m times n. Okay? Okay? Because you multiply those two exponents. Well, you multiply these. And that would be equal to 4 times 2 times 1/2. 4 raised to the power of 2 times 1/2 is equal to 4 raised to the power of 2 over 2, which is equal to 4 raised to the power of 1. Okay? So, the square root of 4 squared is equal to, if we take care of what's inside of the parentheses, the square root of 4 is 2. So 2 raised to the power of 2 is equal to 2 squared, is equal to 4. So that's how we came up with that answer. Okay? Now, the reason why, when you take the square root of, let's say, 4, and you're taking the plus and the minus, is because whenever that's the second root, remember that. What two numbers do you have to multiply together to get 2 is equal to 2, okay? So we have square root of 4 is 2. So we have 2 times 2 is equal to 4, okay? And we also have minus 2 times minus 2 is equal to 4. Because minus times minus is a plus, okay? And 2 times 2 is 4. So you have the square root of 4 is plus or minus 2. Well, usually when you're solving a problem, you don't want the negative answer. So you want the positive answer. And so usually we take the positive answer, okay? Which is plus 2, okay? So that's the reason why there's a plus and a minus, because there's two indexes for that, okay? There's 2 roots, I'm sorry. So it's either 2 times 2 is 4, or minus 2 times minus 2 is 4, okay? Okay, so from there, we can go to a definition. A to the n is equal to, something's going on here. Let me clear this problem here. So, A to the n is equal to b. Okay, b. Okay. So, what we're saying is that a is called an nth root, or a root of order n, okay, of b. Okay. So we have, let's say we have 3 squared is equal to 9. So what we're saying is 3 is a root of order 2. 3 is a root of order 2 of 9. Okay. Since 3 squared is equal to 9. Okay. So if we have minus 5 is equal to the cube root of minus 125. Okay. That's not the square root, that's the cube root. Okay. Because if we take the root of both sides, we can write this as minus 5 is equal to, we can rewrite the above as minus 125, and that root there can be written as 1 over 3, okay? Now, let's square both sides. So I'm going to square minus 5. I'm going to cube minus 5, I'm sorry. Cube minus 5, and then minus 125 raised to the power of 1/3, and then I'm going to cube that, okay? Raised to the power of 3. So minus 5 cubed is equal to minus 125. 3 times 1/3 is 3 over 3. And that's equal to minus 125, okay? Raised to the power of 1, okay? So therefore, minus 5 cubed is equal to minus 125, okay? And why is that so? Because minus 5 times minus 5 is equal to plus 25. So that's, this here is equal to plus 25 times another minus 25, that's 3 of them, is equal to minus 125. So therefore, minus 5 is equal to the cube root of minus 125, okay? Because when the index, which is 3 is the index, if we take a to the n is equal to b, and we take 1 over n of both sides, that's a to the n raised to the power of 1 over n, and what we do to one side we have to do to the other. So that's b raised to the power of 1 over n, and 1 over n times n is just n. 1 over n divided by n is just a to the n divided by n is just equal to 1. Okay, so therefore that leaves a is equal to b raised to the power of 1 over n. Okay, so when the indexes are the a is negative. Okay, and that means that 5 minus 5 is a root of order 3 of minus 125. So minus 5 is a root of order 3 of minus 125. Okay, so let's say minus 2 raised to the power of 4 is equal to 16. Okay, minus 2 to the power of 4, and put a parentheses around that. Okay, is equal to 16. So that's minus 2, 1, minus 2, 2, minus 2, 3, minus 2, 4. That's 4, raised to the power of 4. Minus 2, that's minus times minus is a plus, times a minus is a minus, times a minus is a plus. So that's plus. 2 times 2 is 4, 2 times 4 is 8, and 2 times 8 is 16. Okay? So that's why we know that. And we say that minus 2 raised to the power of 4 is equal to 16. If we take the fourth root of each side, we have minus 2 raised to the power of 4 raised to the power of 1 over 4. I'm taking the fourth root of that is equal to 16 raised to the power of 1/4, taking the fourth root of that. Well, 4 over 4 is 1, okay? So that leaves minus 2 is equal to the fourth root of 16. That's what that means. That doesn't mean the square root of 16. That means the fourth root of 16, okay? And that's how simple that is, okay? So therefore, let's say whenever we have, let's say we have, let me pick one. 81 is the fourth root of 3. So I want to do 81. So let's say 3 raised to the power of 4 is equal to 81. Okay. So if I take the fourth root of both sides, that leaves 3 is equal to the fourth root of 81. Okay. So what is that? Well, that's the fourth root. 3 times 3 times 3 is 9. 3 times 9 is 27. And 3 times 27 is 81. Okay. So that's what that means. The fourth root of 81 is equal to 3. Okay. Let me present this problem to you. What's the fourth root of minus 81? There is no fourth root of minus 81 because there's no number, rational numbers that you can multiply together to get minus 81. Okay? So, whenever you're taking the root of a negative number, okay, the index here has to be odd, okay? Because the only way you can get a negative number is multiply a negative number, an odd number of times itself. Okay. So let's say we had the square root of, let's say we had the square root of 25 ninths. That's the second index. Well, okay. Well, if we got the square root of 25 ninths, that means the square root of 25 over the square root of 9. Okay. How do we know that? Well, back to our exponent operations, we know that we can rewrite this there as 25 over 9 raised to the power of 1/2. Okay. Now we can distribute that 1/2 to everything in the parentheses, which is 25 raised to the power of 1/2 divided by 9 raised to the power of 1/2. Okay? Because from that exponent operation we studied before, we know we can distribute that 125. Because 25 raised to the power of 1 times 1/2 is 1/2. 9 raised to the power of 1 times 1/2 is 1/2, power of 1/2. So therefore the square root of 25 is what? 5. And the square root of 9 is what? 3. And since we're taking the square root, we have a plus and a minus. Okay. And the reason why we know that is because 5 minus 5 thirds times minus 5 thirds is equal to minus 5 times minus 5 is plus 25. And 3 times 3 is 9. And that's how we end up with that. Okay. So let me erase this and start something new here. Okay. So I'll get my pen back. So whenever we have A is equal to the nth root of B. Okay. The symbol is this symbol is called a radical. Okay. Radical. Okay. The number B is equal to radicand. Okay. And N is equal to the index. Okay. So that's all you have to remember. Okay. So it's customarily we write the square root of 25. Okay. But essentially what we're really writing is the square root of 25 is the second root. And if you remember that, you will have no problems with radicals. Okay. So let's say we have the cube root of minus 125. Well, essentially what we're saying is what can be multiplied by itself 3 times and get minus 125. Well, we saw that was minus 5. Okay. The reason why is that because minus 5 cubed is equal to minus 125. Okay. Minus 5 times itself 3 times is equal to minus 125. Okay. The fourth root of 16 is equal to 2. Okay. That's because 2 raised to the power of 4 is equal to 16. Okay. The fifth root of minus 243 is equal to minus 3. Okay. Since that's because minus 3 raised to the power of 5 is equal to minus 243. Okay. When you're writing mathematics, the parentheses let you know what you're squaring, cubing, or raising to a power. Okay. If you write minus 2 squared, the exponent squares whatever is 2 just to the left of the exponent. So if you write minus 2 squared, minus 2 squared is equal to minus 4. Okay? Because you're squaring the 2, you're not squaring the minus. Okay? So this is the wrong answer right there. What you need to do is you need to say minus 2 squared is equal to 4. All right. Remember, the exponent operates on the number just to the left of the exponent. So that's why we use parentheses. Okay. The exponent operates just to the number just to the left. And so here, the exponent operates on the parentheses. And since the exponent operates on the parentheses, you take care of what's in the parentheses first, then the exponent. And that's what you have to remember. And a lot of folks find mathematics difficult because they don't understand the rules. And if you understand the rules, you won't have any problem with mathematics. And you won't get the wrong answer. Okay? Okay, now it's time for us to solve our problem. Okay. So problem number 1. All right. We have the 5th root of minus 32 times the 4th root of 16 divided by the 3rd root of 64. Okay. What was the 5th root of minus 32? Essentially, that's saying, what can I multiply by itself 5 times and get minus 32? Well, we saw that is minus 2. Okay. So that's minus 2. The reason why is because the 5th root of minus 32 is equal to a to the 5th is equal to minus 32. Okay. So what is it that I can multiply by itself 5 times to get minus 32? Well, that's minus 2 times 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 minus 2. Okay, that's 5. 1, 2, 3, 4, 5. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. 32. Minus times minus is a plus, times a minus is a minus, times a minus is a plus, times a minus is a minus. That's 32. So the fifth root of minus 32 is equal to minus 2. Okay. What's the 4th root of 16? Well, we know that's 2. Okay. So 2 times, well, I shouldn't put an X there. Okay. 2 times 2 times 2 times 2. Okay. That's 4 2s. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. Okay. Okay. So that's minus 2 times 2. And what's the cube root of 64? Okay. Well, that's what? 4. Okay. Because minus 4 times minus 4 times minus 4 is equal to minus times minus is a plus times a minus is a minus. So that's minus 4 times 4 is 16 and 4 times 16 is 64. Okay. So we know that that's minus 4. Okay. So minus 2 times 2 is minus 4 divided by minus 4. So therefore that's equal to 1. So the first answer to the first one is up here is 1. Okay? And that's very simple. So that shows you how you can be looking at a problem that seems very difficult, but if you understand the operations, you can solve it. Okay. What's the second problem? Okay, that's just square roots, all to the order of 2. Okay. So we have 3 times the square root of 2. 2 is a prime number, so there's no breaking that number down. Times the square root of 17. 17 is a prime number. And times the square root of 35. What is square root of 35? Square root of 35 is 5 times 7 is 35. So it's square root of 5 times the square root of 7. Okay. How do I know that? From our last our exponent operations right here. Okay. And right here tells us that we can multiply that together, because 35 raised to the power of 1/2 is equal to 5 times 7 is 35 raised to the power of 1/2. Okay. And that's equal to 5 raised to the power of 1/2 times 7 raised to the power of 1/2. Okay. So that's why I can do that. Okay. Divided by the square root of 18 is what? The square root of 2 times the square root of 9, because of the same reason here. And then times the square root of 5 times the square root of 7. Okay. Well, 7 divided by 7, square root of 7 divided by square root of 7 is 1. Square root of 5 divided by square root of 5 is 1. Okay. So that's equal to 3 times the square root of 2 times the square root of 17 divided by the square root of 2. Square root of 9 is 3 times the square root times 3. So therefore, the square root of 2 divided by the square root of 2 is 1. 3 goes in 3 times, 1 time. So all that leaves me is square root of 17. So the second answer, answers the second one is square root of 17. So that shows you how you can be looking at a problem thinking that it's difficult. But if you know the rules, the problem is really not difficult if you know the rules. So when you look at a problem, you see you can solve it. Okay? And that's the answer to the exponent problem and the radical problems. Not very difficult at all.